check. You can also see this. What these tables are involved: person, table pension, table address, also table demographic. The table person and table address are involved, and table state and other tables are involved, or just state, province, and also country, region tables. Okay, if I execute this query, if I execute it, then SQL Server is suggesting this execution plan. Okay. So here, in the middle of the query, after a hash match, we are getting a sort. And this sort is sending its data, which is here, and it is estimated to be 18,000 records are sent to a merge join. Okay? So why do we sort here? Why SQL Server is sorting here? Either it is because we need sorting the query. This is a query. The query doesn't have any ordered by at the end, or group by.
So we are joining it. So in a merge sort, the query, the rows would be otherwise without any kind of sorting.
Right.
Would otherwise be.
It cannot be merged, right?
Yeah, cannot be merged.
So merge sort is what merge sort is doing is starting from the beginning of the sorted arrays and comparing each other and proceeding, right?
Yeah.
So for merge sort we need sorting, okay? And then this is sorted for merge sort. So this is first question he answered correctly. So second question. We have this query, okay, I execute this. And you can see that we have several nested loop joins back to back each other, okay? And cost of all of them are 0 almost, okay? So my question is, can we pipeline all of these nested loop joins?
Yeah, because the weight, none of the weights are too high, so yeah, it can be easily pipeline.
Because as soon as the result of this one is ready, the other one, the other result is coming from index 6. So we look for the other leg of the join, and then we get it from the index, then we join. Then one result is ready, then going to the next line, to the next level of the pipeline. So this can be pipeline. When you see all of these joins all back together, it can be pipeline. So that's why it is faster, and all of these nested loop joins are done with costs of 0 almost. So this was the quiz of today. So I have another.
Professor, I need 2 points, right?
Yeah, you got it. Okay. So I have this query. Just take a look at this query. Let me turn on the computer recording. Okay, so this query is very simple. It has 2 joins in it. You can see we have 2 joins. The first join is doing the join on the table employee and employee department history. And the second join is done on the department history and department ID. Okay? So we know that department ID is the key in the department table. Okay? If I execute this query, sorry. If I execute this query, the result will be like this. Group number, like the count of the people in one group, the title of the people in that group, and the department, okay? So, if you want to give a plan for this query, what are you doing in general? Don't get to the detail of joins and so on. This is a count, this is a group by query. You have 2 joins, you are getting results, then what?
Can you ask the question first?
So the question is, you have this query, regardless of details of join operations, give a brief plan, execution plan. Here's the query. So you have one simple hint over here, right? There are hints over here. What does this hints are saying to you? We told that when we are using sort for what? We are using sort for computing all of the aggregates, because when you are sorting based on the with the sort key of the group by items, group by attributes, then all of the items, all of the rows with the same attribute of the same value of the group by attribute will sit together, right? Then you can easily compute the aggregates. For example, here, if you sort the result of all of these joins based on first job title, then based on the name, what happens is basically then you can just easily trace the result and count and then output the number of people working in that, right? So if I want to execute this query, basically regardless of what happens with the aggregates, if I don't have this count and this group by, what I'm outputting, what I'm presenting to the developer is a column of business entity ID, a column of job title and department name. From the join of these 3 tables, department history, employee department history, joined with the employee. Here you can see that the table of employee has been joined with the employee department history on the business entity ID, okay? And also the department history has been joined with human resources department table based on the department ID, okay? So this is the query. Let me clean this part. So if I go to database, if I go to table of the department, you can see that department ID is the key. Okay. We want to output the name of the department. Okay. So regardless of what we are doing and what we need for the aggregates, if I want to output this, I will do 2 joins and then output this project is 3 columns, right? So if I now want to execute this aggregate, so I need to group by based on these two attributes.
Based on this.
So what I'm doing is I'm sorting based on these two attributes, then
Counting.
easily counting. So let's see. Okay, so basically what we are doing is we are simply scanning two indexes, clustered index, and then hash matching to clustered index. Okay, we can, instead of hash match join, we can use another join. What kind of join we can use? Note that employee department history has the key of employee business entity ID and also department ID, right? This is the key of the department employee history. Employee department history, okay? What is the key in the employee table? Business entity ID. You see two common part in the keys, right? Business entity ID in the employee table, business entity ID in the department employee department history. So, and the prefix of the index. What is the prefix of the index? The index is in the employee department history is first based on employee, second based on what? Department ID. Department ID. So then what we are doing is we can get benefits of this feature. Since the department ID, employee business entity ID is used for both of the tables, then we know that both of the tables are sorted based on first business entity ID. So instead of hash match join, what kind of join we can use easily also here? Both of them are sorted based on the join attribute. Join attribute is business entity ID, and you know that this. See, this is a sign of cluster index. This is the sign of clustered index here. You can see that, right? It's a tree and then the flash, it means that we go to the tree and traverse it, the tree. So, since both of them are sorted, which kind of, what kind of join can we use here? Merge sort, right? Merge sort means join sorted. Then with merge sort, again you can go with one scan. Also hash map. So in this case, both of them are applicable. So okay, so then after this, what we are doing is we are basically retrieving we are joining the rest of the results together, and then finally sorting, right? After sorting, what we are doing is stream aggregate. What does it mean? It means that go through the table, count, basically because everything is sorted now. So, for example, start from like Department of Engineering, and also start from the engineers. You can count, and you can see that this number of the engineers are working in Department of Engineering. In the Department of Sales, you can count the number of the engineers, you can count the number of the salespersons, and so on, based on just tracing. Okay, is that clear? We have seen this in one of the questions, right? This query. Have we? Do you remember this query? Right, it has right join.
Yeah. Yesterday's
Last week, so
Last
week.
Okay, this has a software instance. Okay, so suppose that you have this query. Consider the following query. You can see that query, right? Can you? Give the execution plan for this.
We're getting all the people whose title is null and we're getting all the business entities of them, and we are using
Hajat, you go.
We are giving the business entity ID and we're addressing from all the people whose title is null.
Okay, so first we select people whose title is null. If their title is null, they don't have any title, then what we are doing, we are showing their email address, right?
Yes.
Probably we want to ask them the real title. Okay, so how do you solve this query? How do you process this query? How do you give an execution plan? To give an execution plan, what kind of information you need at the beginning? How can you solve this problem? You can solve from bottom up part first. For example, compute this subquery, see who does not have any title, then go and
hash join with
save them, and then use hash match or other types of matching with this the result of the main query. So one way will be computing this one first, and then using this join and filtering all of the results of this join based on this compute. What is the other way?
first joining the two tables.
First joining the two tables, then going and selecting, finding all of the people without any title. Then when you find the person without any title, go and remove, go and pick the people from this one, pick the same person from here, and put it in the output.
How do we know which one is better?
Okay, so
The first one will be better because when we are joining two tables, we'll have less business entity IDs, so join will be easier.
right,
The second option, like we'll have a lot of things to join in the table.
right.
If total two tables should be joined, it will be like more cost. Second is not good.
Right, but if the result of the subquery is very small,
Then it is.
then it can be fitted in the memory, right? Then you computed the result will be returned, you computed the memory, while you are doing the join the other one, then you pipeline, right? And do the rest. So, I should, oh, sorry, I haven't done this. Okay. So if I execute this, what happens then? Okay, so forget about who is done first. We have a pipeline over here. Okay. So one more thing is the ID is cluster, but we are not seeking on that. Oh, okay. It's very clear. So what we are doing is we are doing this join. Okay. So do we have any pipeline here? Bahadur, do we have any pipeline here? Can we have a pipeline? These are back to back each other. As soon as the result of this one is ready, then you can look for the result of this one and join it. Okay? So we have a pipeline. Okay, good. So, sorry. Now, suppose that we are doing the first join, the join of the main query. Both of them, you have one clustered index, one non-clustered index, you are doing nested loop join. Okay? So, as soon as you are joining, when you find the record in a join, what you are doing is you have a clustered index sick. Because why? Because table of person has a business entity ID as a key, right? So what you are doing is the result of this join, What does it have? The result of this join. What does it have? What are the output of this join? Does it have any business entity ID or not?
No.
It has only email address.
No, it has.
It does,
It has.
right? It does. So here, you see that the output list is business entity ID. So it has a business entity ID because it needs business entity ID for the next step. So you have the business entity ID. So then the other table is indexed based on business entity ID. Just go to the table and find if the person, find out if the person has a title or not. That's it. If it doesn't have title, just out.
So here first it is joining the two tables and then it is taking the business entity like
actually,
that.
you are not doing one first and the other first. You are doing pipeline. Both of them are at the same time.
Same.
Right?
Here it is showing.
Okay, so this was one example. Okay, we did this. Okay, so give an execution plan for this query.
The same, Professor.
The same?
The same.
But phone number is
The extra part we'll do it like we'll add the phone number. The last in the last subquery.
Okay, so let's see.
But this is one more query and
What Khaja?
one more query and is there.
Yeah, here is I have and here.
Yes.
That is the only addition.
Okay, so are you sure that it's exactly the same?
Almost the same.
Can we do a pipeline and checking the AND condition can be done in the pipeline? Yes, why not?
Why?
Yes. So the first part.
Joining the tables.
The first part, as Fanindra and Khaja mentioned, there are two tables joined with the nested loop, similar to what we had in the previous one, exactly similar. Okay. We have a cluster we are retrieving the person's table, person's record, exactly the same as previous one, right? Can we do it as a pipeline? Yes.
Yes.
Why? Nested loops back to back each other. Then the result will be hash map with what? Business entity address. Okay. So this is an index, a scan. Why is it a scan? What is the output of this?
Business ID.
Business entity.
Look at the output. Sorry, this is not coming up. Okay, this is the output. First item. First item is business entity ID. Yes, Megana, right? So why do we scan the index? Why don't we stick the index? This one, this leg of the joint, this partner of the joint, the first item in the output list, what is this? Business entity ID. Okay, and also, what table is this? Business entity address. The key of the business entity address is address ID and business entity ID, right? Isn't it? Then the table, the records are sorted based on first business entity ID, then address ID. So then business entity ID is the key, the sort key. Okay, the attribute of the sort. Then it is sorted based on business entity ID. Okay, this is one part of the join. What is coming out from this nested loop join? Here, the output of this table, in the table employee, what is the key? Business entity ID. So if we scan this table, the output is sorted based on the business entity ID. It's coming here for the next step of the pipeline. Here we are using person phone and we are seeking the index. So we find phone of the person, joining it here, sending it to the next level of the pipeline. Still, the result is sorted, the result is outputted based on business entity ID. So business entity ID 1 is coming out, 2, 3, 4. So far, everything is sorted based on business entity ID. Here, output of this join, the first item is business entity ID. Because, again, we are doing indexing, and because we still have the business entity ID as the sort. It's pipeline. Business entity ID 1 is getting to the pipeline, getting out of the pipeline business entity ID. Business entity 2, output. So since it's the pipeline, everything is keeping the first okay, so then let's get with this one. Which one was we were talking? Okay. Here. What is the key here? Business entity ID. So what do we need to do here? Just look for the business entity ID we have in hand. It could be basically what? Cluster index. In the cluster index, we are looking for something. As soon as we find the person, we are done with this join. We are sending it out, this hash match join. This is also can be done in a pipeline. Why? The result is ready. The result is ready. What is the other leg of the join? Index scan. You are scanning it, this one, and just hash matching it. And finally, the last join. Last join is done with address, with the hash match, and select it out. So this was it's great. Okay, now let's do some work on okay. Suppose that you have this table. Suppose that you have this set of objects defined for the students. Okay? Suppose that you have this student type. Okay, suppose that we define this as student type. Okay? Write a create table query to create a table of the students with reference. Try it now.
Create table?
Write a create table to keep the objects of the students with reference to a student as a student OID. Yeah. Write a table. You can write a table like this. Which one is the creating a table? Right? I told you that the student type ID, the student type is defined here. You are asked to create a table for students, the object of students.
Yes.
This is a simple create table. Okay? You want to add one reference to the students because you want to use reference ID later. So, which one is used? ref is the student OID. It means that you have this reference available. Okay?
We can add it after creating the table.
Right. No, this is another create table. You are not altering the table. This is another definition. That was the first definition without reference. I just show you how easy it is. You have this student type, then you can easily create a table of a student type. That's it.
Can we alter the table as well?
Yeah, you can. You can alter the table.
So if we want to create with the OID, then we have to first create a student one, and then we have to do this.
No, you don't need to.
And what's the direct query?
Just the create table.
Directly create table with ref is student entity.
Right.
Can we inherit two student types
Inherit two student types from each other?
into a single table?
No. If there are different types, that cannot put in the same table.
I mean, one table may contain name and ID, and the other table may contain the course.
Oh, you want to
Join.
create a table of person and then create a table of students, right? So then you need to have a new student ID. Sorry, student type. You need to have a new student type where you need one pointer to person, right? One reference to the person. Okay, so this is a table of transcript I created. Okay, so what this table says.
We are creating a table named transcript where we are referencing
The first attribute is reference to
Student type.
student type.
from where, from which table?
Student table.
Student table we created in the previous slide. Okay. So
all the variables available in the student two are taken here.
right.
Is
No,
like no, is
no,
there
you
a
just
part?
put a pointer over here.
It's like a part only. They will
Right.
just put the point. They will
Just
not
to
add
put-
anything.
No, yeah. Okay, you have these two tables. Okay, write a simple query. Where is this notepad? Oh, yeah. Okay, so I should make this. How do you write this?
We need to use those to create newly created tables.
Yes, you need to use this. Everyone is done? Should I write it? Should I write it on the whiteboard because you can see the design of the table? Or I should write it over here? I write it over. What do we need to select?
S dot name and S dot ID.
S dot or S slash?
Slash.
Because the first attribute is pointer now. If it's a reference, okay. So the name it was name or
Name.
capital or lowercase?
Capital N.
It was another.
T dot T ID
ID
from student.
student or from where? Course. Where is the course?
Course is in transcript.
So if I find people who took the course, then that's it, right?
Yeah.
From transcript. Where?
Student course ID.
What was CRS?
CRS COD.
CRS ID equal to
CS.
Course code I think so we have.
course code. I don't remember it. What's this? This was right. Is that correct? Is that correct or not?
But we did not declare the pointer.
The S is this the S is the first point of the, was it the S or a student?
Student.
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 Student, right?
Yeah.
That's the name. The name of the student, yeah, right? This is the name of the attribute, right? So the student is referring to the student. Okay, so multi-set. We have multi-set query, multi-set tables. So suppose that we change the student table, the student type, where we have a reference, to course type, which is a multi-set, which is not one attribute, it's a set. Okay. So the enroll is pointing to the course type. Okay. Do we have course type here? No. Okay, so suppose that the course type, we create the course type as follows. You see, people are very surprised on ending the semester. Okay, so this is the course type. Right there, simple query. To show all of the students who either took CSE or either enrolled in CSE 1 or a course, so 1 credit. display, make it smaller to see the course type. Okay, so
You want student name, user?
so what was the question, Sudhir?
You want student's name?
This is going to show all of this, the name of this, the name of and ID of the students. Money is consulting. We want to see one example from the slides.
Can you go up?
Well, onset. Do you remember this query? We have this onset operator, which is extracting one set to a table, right? We are onsetting as an E. E will be a pointer to table. Okay, it will be a table, course code of the table. Okay. Similar query, it's very similar.
Yeah.
Who wants to write it on the board? Who wants?
Professor, we are using the transcript.
We don't use transcript.
We are just using the student report.
This is
Can you
this
go
is
to
a
the
new
WordPad
definition of a student, right? It
Can you
has
go to
this
WordPad?
enrolled. What is? It has this multi-set. Oh, look. Ready to write it? Hi.
Can you open the WordPad?
WordPad. Shashikar, you want to write it over here? We can help you. Come over, I will help you. We'll write it together. You want to write it?
Money was right.
Go.
Just let's see other people.
I can try.
Yeah, I mean, let's other people to engage. I mean, you are the boss, you know. The cell phone that is running Microsoft SQL Server. You should write for you. Come on. So, who wants to? Shashitari wants. Come over, we have write it together. Okay. Okay, so hold on. This is the answer for. Okay, this is the sample query. Let me give you more. Okay, so first you have to select what? Right, select. What do we want to output?
Name and ID.
Select S ID and S dot name, right? Right order. Start from up because people cannot. And it will go to the left because people will. Select S dot ID, S dot name. Okay. So from where? From students. From the students. Right? Do we need course table?
Transcript table.
No, what transcript? We have enrolled. Enroll is shown.
Course is required for submit.
Do we need course table here in the from?
Yes, Professor.
Yes, Professor.
Why?
We need.
Because we are will be taking C dot course code in the registered courses.
But we don't project anything from the course. If you put course here, then it will be using Cartesian product, right?
Oh, okay.
This is the from clause. We are not getting to that part yet. So where from which is what is the condition? Where? Right.
C dot course coding.
Right, course code. I see that course code, but
There is no course code in the students.
Of course,
We
name.
need the course code.
we don't have course code over here. So let's see. What is it? Exist. Now here should exist. One set exists. You have this exist, right?
Yeah.
What is existing? Now write the rest similar to this one. Select E pointer course code from onset similar to exactly this one. Yeah, from onset S dot enroll. So we forgot to add S here, right? Student. Oh yeah. This class. You choose this one. This one is good. Okay. You have still we need to put the where clause here. Where? What is the condition?
Course code equal to
Course code equal to
CSE.
CSE 551. Where CRS code is equal to CSE 551. Are we done?
No, Professor.
Okay, so we still need to do one thing. This is one part.
But
This is
where
one
do
part.
We don't have the credit card.
Okay, this is one part. Union. You know what? Next, another query. This is better. I like this. This is a good choice. Yeah, find a good point. So, again, similar to this one, until to here, similar to this one, right? Select E course code.
Professor, where will be the E?
Where is the E?
It should.
From
be on the
onset,
list, right?
this should be E, right?
Yeah.
From onset, S dot enroll, Multiply as E. Okay. So again, right until here, everything similar, right? Everything. Right. Select
దాంట్లో కోర్స్ నేమ్ ఉంది
E.
ఉన్నో తెలియదు
course code from onset and what else? We need one more table here. Which table? Course. Course, not transcript. Course has credit in it. Well, and course, COURS. Like it as a capital C, right? Because it's easier than this. Where? Okay. So where what?
Credit equals to
Where? First of all,
Where
let's
C
do
dot-
the join. E course code is equal to C dot course code. The join condition. E slash E dash. Should add this arrow, right? Because E is a pointer. No, C is not pointer. C is a table. C is a table. C dot course code. And what? C dot credit is equal to 1, right?
Even the where clause E pointed to course code is equal to CSC 551.
When you so
Before
this
the
is-
union, it is
So we are
not
done.
just course code.
Okay, so we get the credit. Okay, thank you. So
It's like where course code E pointed to course code is equal to CSC 551.
here,
Where
because
here,
yeah, E pointed to course code is
yeah, E course. Is that easy or not?
can we not why we need to union process? We can write that sequence also here in a single select statement.
Yeah, we can, but yeah, I wanted to make it easier. One part. So, okay, thank you very much. It was a pleasure for me to have this class. Good luck with your exam. See you on Tuesday for the project and see you on Thursday for the exam. Okay, the same time. Yeah, it was the last class. So, people are very happy.
Professor, the grade, still not a grade.
You're a student.